Welcome. What I want to do today is show you how to solve this quadratic equation by completing the square. So completing the square is a process that has some steps that we're going to go ahead and follow. The first thing I like to do, it's not really a step, but always to make sure when you're going to be completing the square, or really doing any math problem, you always want to look, can you simplify the problem, by maybe factoring out some common numbers or maybe rearranging it. Well, this quadratic is in descending order, which is good, and I also noticed there's no common terms that I can factor out. So what I'm going to do is I'm going to get on with the process. So the first part about completing the square is you want to make sure you have your a, remember the quadratic form, ax squared plus bx plus c. And as long as you need to make sure that your a is going to be equal to 1 when you're factoring it out. So I would say, factor out a if needed. Well, as you can see in this problem, my a is currently a 1, so I don't need to. However, if it was a -1 or if it was a 4 or something else, then there's a different process that we have to go through, which I could show you in a different video. So for here, what we want to do now, completing the square, is we need a way, and remember we need to solve for our p squared and pu. So we have two of them. We cannot combine them because they don't have, they're not common terms. And we can't just solve for one of them because we have two of them, right? So we can't solve them like a linear equality and linear equation, nor can we combine them. So what we're going to do is we're going to get our 57 on the other side. So we're still going to want to isolate them, just like a linear equation. So I have p squared minus 16 equals now a positive 57. That's negative 16p. Okay, so our goal for completing the square is to get a perfect square binomial, meaning a binomial that's going to multiply by itself. So to get a binomial that's going to multiply by itself is going to produce a perfect trinomial. And how are we going to get a perfect trinomial? Well, to do that, we're going to go on to step number 2. So to do that, I'm going to take b divided by 2 and square it. So therefore, I now look at my b, which is a negative 16, b, negative 16. So I'm going to take negative 16 divided by 2 and square it. So negative 16 divided by 2 is negative 8. Negative 8 squared is positive 64. Then I'm going to add to both sides. Alright, so when I add p squared to both sides, or 64 to both sides, I get negative 16p plus 64 equals 57 plus 64. So why is the whole reason of doing this? Why did I want to get this b divided by 2 squared and 64? Why do I want to add it in there? Why do I want this perfect trinomial? Because, I'm going to show you. By adding 64, I have now created a perfect trinomial, perfect square trinomial. Well, what is so important about this perfect square trinomial? We can rewrite this as p minus 8 squared, which now is a binomial squared, and that's exactly what I want. What I did was, you think I was not getting more simplified, but now I can rewrite it now as just p minus 8 squared. Notice, by writing it as a binomial squared, I now only have one variable p. So that equals 57 plus 64, 121. So now what do? Now we can just use the square root property. Square on both sides. So I get p minus 8 equals the square root of 121, which is plus or minus 11. Now, add 8 to both sides, and I get p equals 19, and negative 11 plus 8 is going to be also p equals 19, and p is going to equal negative 3. So there you go, ladies and gentlemen. That's how you solve an equation using completing the square. Thanks.